You are listening to the official radio station of President Quirino National High School. This is 98.7 PQNHS Shine FM. Mapya mapita, naimbag na bigat, maayo nga aga. Good morning, good morning, good morning to our listeners, especially our dear new normal learners from grade 12 STEM. This is your school on the air for science, and we are glad because you are with us in our alternative delivery mode of education through the use of this radio-based instruction blended with modular approach. I am Edward Casero, a senior high school science teacher, your host for today's episode. Make sure that you are in an area where you feel comfortable and can clearly hear our broadcast. And make sure that you have the following materials for your next activities. First, of course, you must have your module, your ball pen and a highlighter if necessary, your notebook for note-taking, and paper for your exercises and short quiz later on. Do you have already the mentioned materials? Very good. Before we will proceed with our topic today, we will have a review first on the lesson we have discussed last time. So yesterday we have discussed about the definition and the difference between accuracy and precision. So what is accuracy and what is precision? Accuracy is defined as the closeness of the measurements to a specific value, while precision is the closeness of the measurements to each other. The set can be said accurate if their average is close to the true value of the quantity being measured, while the set can be said to be precise if the values are close to each other. We hope that you can still remember those things. So now, please get your paper from yesterday's quiz because we will check your answers. So here are the answers of your quiz last time. The answer for number 1 is true. Number 2, false. Number 3, true. Number 4, true. Number 5, true. Number 6, false. Number 7, false. Number 8, true. Number 9, true. And number 10, true. Okay, and now let us check your assignment. That is activity 2.3 on page 12 of your module. So please turn your module on page 12. And take a look at the table. Okay, so based on the given data in table 1, which balances are precise and accurate? So here is the answer. Balance 1 and balance 3 are accurate because the values given are closer to the standard values or specific values. On the other hand, balance 2 and balance 4 are precise because the values given are not closer to the standard values or specific values. So how many correct answers did you get? We do hope that you have answered our quiz last time logically and full of understanding. And take note, we will have a quiz again later, so you need to listen carefully and focus your attention to your radio teacher. Again, you are encouraged to write down those important points of our lesson for you to easily answer the questions that might be asked to our quiz later.
No problem. Tangin ang sulat ko kung gusto ko magsulat.
Okay, and now, our dear new learners, please prepare yourselves for we are about to start our lesson about errors in measurement. So I believe you are now ready to listen, learn, and level up. Since you are ready, please listen to your radio teacher for today's lesson, Sir Ken Lejero.
Good day, our dear new normal learners from grade 12 STEM. I am your radio teacher for today's class, Sir Ken Lejero. Last time, we have discussed the definition and the difference between accuracy and precision. Now, we will move on with our new lesson, which is about the errors in measurement. I am anticipating that at the end of the lesson, you can be able to differentiate random errors from systematic errors. But before anything else, I want you to turn your module on page 10 to 11 and answer activity 2.2, and I'll be giving you 3 minutes to do the activity. Please don't forget to read the instruction before answering. Your 3 minutes starts now. I think you did the activity very well. We will check your work later. So now, what comes to your mind when you hear the words errors in measurement? Sounds familiar, right? I know you have ideas about these things, and upon listening, you will know more about it. So now, turn your module on page 12. No matter how careful you are, there is always an error in a measurement. Error is not a mistake, it is part of the measuring process. An error may be defined as the difference between the measured value and the actual value. For example, if the two operators use the same device or instrument for finding the errors in measurement, it is not necessary that they may get similar results. There may be a difference between both measurements. Now, the difference that occurs between both of the measurements is referred to as an error. And in science, measurement error is called experimental error or observational error. Now, there are two broad classes of observational errors. What are those? The random error and the systematic error. Now, what are the differences between the two? Random error leads to fluctuation around the true value as a result of difficulty taking measurements. This is a naturally occurring error that is to be expected within an experiment. Therefore, random errors are unavoidable and primarily affect precision. Random error can be caused by the sudden change in experimental conditions, such as changes in humidity, unexpected change in temperature, and fluctuation in voltage. Other causes of random errors are the noise and tiredness in the working persons. So here are the examples. Number 1, when weighing yourself on a scale, you position yourself slightly differently each time. Number 2, when taking a volume reading in a flask, you may read the value from a different angle each time. Third example, measuring the mass of a sample on an analytical balance may produce different values as air currents affect the balance or as water enters and leaves the specimen. And last example, measuring your height is affected by minor posture changes. Because random error always occurs and cannot be predicted, it is important to take multiple data points and average them to get a sense of the amount of variation and estimate the true value. Another experimental or observational error is the systematic error. Systematic error leads to predictable and consistent departures from the true value due to problems with the calibration of your equipment or instrument that affects all measurements. Instrumental error occurs due to wrong construction of the measuring instruments. Therefore, it primarily affects a measurement's accuracy. Here are the examples. Sample number 1. Forgetting to tear or zero a balance produces mass measurements that are always off by the same amount. An error caused by not setting an instrument to zero prior to its use is called an offset error. Example number 2, an improperly calibrated thermometer may give accurate readings within a certain temperature range, but become inaccurate at higher or lower temperatures. Thus, systematic error can be eliminated by using proper technique, calibrating instrument or equipment, and employing standards. To sum it up, random error causes one measurement to differ slightly from the next. It comes from unpredicted changes during an experiment. On the other hand, systematic error always affects measurements the same amount or by the same proportion, provided that a reading is taken the same way each time. And systematic error is predictable. Furthermore, random errors cannot be eliminated from an experiment, but most systematic errors may be reduced. I hope that you have learned and understood the difference between random errors and systematic errors and be able to identify whether a measurement is caused by random error or systematic error. Once again, this is your radio teacher, Sir Kent Nero, for the School on the Air for Grade 12 Science. Thank you for listening. Till our next lesson. By the way, if you have some queries or clarifications, Sir Edward Casaro will have a recapitulation of our lesson for today. We will also have a quiz regarding the topic we have discussed later. So do your best. Good luck.
And that is Sir Ken Behero, your radio teacher. Today we have learned and understood the difference between random errors and systematic errors. If you have any questions or clarifications, we have a recap of our lesson after the break. So don't go away. You are still listening to 98.7 PQNHS Shine FM. A while ago, Sir Kent Behero discussed this lesson about the errors in measurement. Please check your notes for we will have a recap about this lesson in preparation with your quiz later. Let's do the recap. So again, random error leads to fluctuation around the true value as a result of difficulty taking measurements. This is a naturally occurring error that is to be expected with any experiments. Therefore, random errors are unavoidable and primarily affect precision. On the other hand, systematic error leads to predictable and consistent departures from the true value due to problems with the calibration of your equipment or instrument that affects all measurements. It is very important for you to understand the definition and the difference between random error and systematic error because these are commonly experienced during measurements. It also helps you to be aware and to know what to do in order to reduce the said errors. Now that we have already done with our discussion, it is time for us to test if you really understood our lesson today. Are you ready? Please get ready for our quiz. Please prepare one sheet of paper and your ball pen. So I will give you 1 minute to prepare your 1/4. Okay, in your 1/4 sheet, please write your name, your section, and the date today. So this is a 10-item quiz. What you're going to do is to identify the statement or phrase that I will be given. Then you will write down if it is a random or a systematic error. So write your answer in your 1/4 sheet of paper. I will read the statements or phrase twice, so you must listen attentively. Okay, so let's begin. Number 1. Poor calibration. Poor calibration. Is it a random error or systematic error? You can write the word random only or systematic. Number 2. Observer reactivity. Observer reactivity. Random or systematic error? Number 3. Sudden changes of temperature in the laboratory. Sudden changes of temperature in the laboratory. Number 4. Use of new flow measuring tape versus an older stretch one. Use of new flow measuring tape versus an older stretch one. Number 5. Different instructions by different administrators. Different instructions by different administrators. Number 6. Outside or inside noise in the room. Outside or inside noise in the room. Number 7. Intrapersonal errors. Intrapersonal errors. Number 8. Number 8. Instrument-related factors. Instrument-related factors. Number 9. Wrong position of yourself when taking a volume reading in a class. Wrong position of yourself when taking a volume reading in a class. And last number 10. An improperly calibrated weighing scale. An improperly calibrated weighing scale. Okay, so that ends our quiz for today. I hope you answered and identified it well. So we will check your quiz tomorrow. Another lesson is delivered again today, and I hope we have learned and understood a lot. So for your queries or clarification, you can also text or call your subject teacher in this cell phone number. So please take note of this. 0966-665-4341. Again, 0966-665-4341. So do not hesitate to send a message or call to your subject teacher. Okay, so before we will end, I just want to remind you that your next lesson is about measurement data presentation. Again, together with your radio teacher, Sir Ken Quijero, and another host, Ma'am Angelica Olpindo. That will be tomorrow. So make sure to stay tuned on our official radio station 98.7 PQNHS Shine FM for more updates. So again, this is your host, Edward Casero, saying some of the best lessons we learn are learned from the past mistakes. The error of the past is the wisdom and success of the future. Till tomorrow, paalam!